Today, we're going to show you a short microservices demo of our GitHub project using Opentracing and Jaeger. We'll give you the URL at the end of the video so you can download the source and run it for yourself. Our demo app is a Scrum management tool, a rudimentary Jira, chosen because we're all familiar with Scrum, and so there's no need to explain the business domain. We've implemented 7 microservices, each with its own data source, along with a UI. Messages between microservices are routed via a message broker. This is because we're using an interaction-centric model in which we broadcast messages to let other microservices know what's happened, rather than requiring microservices to call each other directly. This allows us to keep services independent whilst giving significantly better performance. One inherent problem when working in microservices is that they are decoupled and so have their own log files. This makes it hard to understand the flow of execution between microservices, the call graph. We're solving this here with Opentracing and Jaeger. Opentracing is a standard for tracing events and includes key information about interaction, such as where it's coming from, where it's going to, the transaction reference and the type. This means that a monitoring tool, such as Jaeger, Zipkin and Hawkula, can link a set of interactions together, using the transaction reference and timestamp to form a trace representing the entire transaction. The trace is comprised of timed units of work called spans. These are hierarchical and contain information such as tags and associated contextualized logs. This is the insight that allows, for example, a developer to debug a distributed system, or an operations team to filter performance monitoring according to business context. Opentracing is standards-based and flexible. For example, events are only generated if you choose to run a Jaeger or similar agent. It's also possible to raise or lower the frequency of Opentracing events through configuration of, for example, environment variables. Indeed, our developers find Opentracing to be very unobtrusive, with virtually zero impact on the system performance and no errors or delays if Jaeger is unavailable. We're using Minishift, meaning we can run OpenShift locally by launching a single node cluster inside a virtual machine. Build automation is done using Ansible. Full instructions and scripts for setting this up are described in our GitHub project, so we're cutting straight to the OpenShift Management console, where our scripts have created a project called Scrum Management Demo, with applications for each of the microservices, a deployment for the database, and a message broker. So, here's the problem. We have 7 microservices in a user interface. If we deployed this to production, we would, as a bare minimum, need 2 load-balanced nodes, meaning 16 microservice instances, each with its own log file. If we had a problem with a live transaction or process, we could look at each of the 16 log files to try to determine what was going on, but that's slow and painful. We've tried it, and assumes the developer of each service has logged the information that we'll need. It doesn't give you a combined picture. This is what Jaeger's doing. Here we can see spans, timed units of work, across the set of participating microservices. For a given trace, we can read how long it took, for example, to retrieve information on a project or use a story, broken down into the contribution each microservice made. Looking more closely, we can see the identifier, type of component, time taken, URL, HTTP headers, database access, and so on. We can also see tags with contextual information, the hierarchy of calls, and then drill down into quite low-level operations, like the select statement within the JDBC call. From the obscurity of many logs, we now have a very simple way to visualize how a business operation is broken down. Opentracing supports many libraries for different languages, such as Java, Python, Go, Node.js and Ruby, as well as frameworks, Java examples including JEE, JMS and JDBC. This means there's lots of support for instrumenting your code. Let's take an end-to-end example. Creating a new Scrum project calls the project microservice, which updates a sequence in the database before publishing information to a topic. The sprint microservice picks this up and inserts a new record into the database, and itself publishes a message to tell other microservices about this new sprint. Next, a product burndown is created, which adds rows to its own data store and so on. Because there's a common identifier, the traces can be stitched together by Jaeger to give you the end-to-end story. This means you can start to look at things like performance. like this microservice is hitting the database multiple times when perhaps a single SQL batch statement would be more efficient. Indeed, Jaeger democratizes performance analysis, allowing developers to optimize their code, architects to analyze the system as a whole, and operations team to resolve production issues. Sometimes we need to identify a specific trace from the large amounts of information we have available. Perhaps a transaction has caused a downstream problem or is stuck somehow. By using the tags as a filter, we can isolate traces, in this case relating to a particular user story. This trace shows a task being added to the story, causing that story to change state and triggering change to the product burn down via a different microservice. As well as filtering on tags, Jaeger can also flag errors, allowing you to drill down into the trace and then show you contextualized logging about that error. Because of the libraries we are using, this functionality comes for free. Anyone who debugs live systems will recognize that anything which demonstrates how an error occurred and not simply where is a massive time-saving feature. Instrumenting the code is simple. Here we have a Spring Boot application. We've added libraries to the POM for Opentracing and Jaeger, the Spring Cloud library giving us automatic instrumentation for REST controllers, templates, and Spring MVC. This means that, without having to add any code, an Opentracing event gets created every time you click a link to go to a view. This keeps our application code clean. Adding business context through tags for filtering in Jaeger is also easy. In Spring Boot, the application is configured by creating a Jaeger tracer. We now have a number of patterns that make it easy to get good coverage in Opentracing without having to add much, if anything, to the application code. We've also found it useful to control configuration through environment parameters, meaning that, for example, we can set up dev or test differently to production. We've learned a lot through building microservice architectures. Establishing distributed tracing and monitoring has proved important for developers debugging across microservices, as well as ops teams monitoring and diagnosing live environments. We are now looking at how instrumenting with Opentracing can be a much cheaper way to demonstrate compliance to a regulator, for example in MiFID II and GDPR. Our approach is to inject Opentracing into legacy platforms to help everyone understand what's really going on, and then map existing events to the regulator's process. If you'd like to download this project and get running with Minishift, the instructions are on the Estafet GitHub. Drop us a line to tell us how you're getting on. We're keen to discuss ideas and where this technology might take us.